We had 15 students say that B was the answer. 6 students say that C was the, 6 students said that A was the answer. So let's do another revote now that you've experimented with it. How many of you decide that A is the correct answer? That it's going to rotate in that same circular motion once it leaves your hoop? I got one. How many of you say B is the correct answer? All right. How many of you say actually C is the correct answer? Okay, thank goodness, because you'd be on some weird planet if C was the answer. B is actually the correct answer. So what I want to emphasize is as you are rotating an object in circular motion, this is my marble. This is the direction of rotation. What type of path would it take in this direction once I lift my marble? What type of path would it take? Alexa? Diagonal path?
Like if you lift it, like where you put the marble,
kind of diagonally. Let's actually look at it. Mine is a little bit in a different location than my video here, but if we actually watch this in slow motion, where's my video? Hold on, it's here somewhere. Here it is. Okay. So if we actually watch it, oh, my marble's going in a different direction. Once you lift the marble, it goes in that kind of straight line path. This one was rotating, what is that? Clockwise? Counterclockwise. So this is rotating clockwise. If I lifted it here, it would actually go, and I didn't draw it perfectly, but it would go in that path. We call this tangential velocity. Can anyone tell me why it goes in this path? Hold on, I can't even see if hands are raised. Velocity. Rachel.
Because it keeps going the same velocity.
It wants to keep going in
its direction.
It keeps wanting to go in the same velocity. Anything else to add to that?
Like it has some outside force. But now when you let go, it's just going to go whatever way it was
in that particular moment. So the only reason why it went in circular motion is because we had an outside force, right? We had a hoop. Once we eliminated that outside force, what does Newton's law tell us? What is it, James? An object in motion wants to stay in motion, but not just any motion, constant motion. And when I say constant motion, I mean a straight line, constant velocity. So once I let go of that outside force, it's going to move tangent to the circle that it's moving in. So tangent meaning, we talked about tangents in the previous unit, it's going to be kind of parallel to the circle at this moment in time. So that's my tangential velocity right there. Now, Alexa talked about a force. When we're doing circular motion, my hoop at this point is right here. What direction is the hoop pushing the ball in? James?
Right.
It's definitely pushing downward, a little bit to the right to get it in circular motion, maybe? It's actually straight down. This is supposed to be a straight line, straight down into the center of the circle. We call this centripetal force. So no matter where you are, you're always going to have a force pointing toward the center of your circle. We also have something called centripetal acceleration. So we have this equation, the sum of the forces equals ma. And we know that the mass of our marble doesn't change, right? So if I were to increase the force, what happens to my acceleration? It increases. If I were to decrease the acceleration, what happens to my force? it decreases. We have a direct proportion for force and acceleration. So if my force is pointing this direction, downward, what direction do you think my acceleration is going to point also? Any thoughts? If force and acceleration are directly proportional, if my force points down, what direction is my acceleration going to point down? It's going to point down. So force and acceleration for centripetal motion, and we call this AC, which is centripetal acceleration, they're going to always be pointing in the same direction, always toward the center of the circle. So this is the center of my circle. All right. How about velocity? Let's talk about the speed. When you used a smaller hoop, did you notice anything about the speed of that marble? Any thoughts? The smaller the hoop, what did you notice about the velocity? James? It was faster. You didn't have to use that much force. It would go fast even with a little push versus a large hoop. And with a large hoop, sometimes you had to really spin it multiple times to get a good speed or a higher velocity. So with smaller radii, you get higher speed and higher acceleration. So let's look at our lab because we're going to collect 3 things. First of all, I told you many, many times that acceleration is a change in speed, but it's also a change in direction. And a lot of students don't believe me when I say that even though you're moving at a constant velocity or a constant speed, that you also have acceleration if you are moving in circular motion. We're actually going to test it out today. We have 2 pieces of homework. One is to take notes on chapter 9 on a separate sheet of paper. The other one is to finish this lab. And for those of you who need to do a real lab CEO resubmission, make sure you get that to me by Monday.